Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Okay, today we are looking at this question. It says, define electric field. Okay, so what is it? Okay, electric field is a region of space where a charge experiences a force. So when you put a charge at a particular point and that charge experiences a force, then that is what we call electric field. So then comes this question. It says, define direction of electric field. So what is it? Okay, direction of electric field is the direction of the force exerted on a unit positive charge placed at that point in electric field. So that's the direction of electric field. So when you put a positive charge in electric field, the direction it takes is what we call direction of electric field. So we use the positive charge as the yardstick for the direction. So that is that. Then comes this question. It says, draw electric field pattern for each of the following. The first one is isolated positive charge. Okay. What do we call isolated positive charge? Isolated means that this charge does not have any charged neighbor around. So it is alone. Okay. So if it is alone, what will be the pattern? What the pattern is that it will radiate outside like that, in straight line. So this is how the field lines will be. And then the direction. What's the direction of this pattern? Like I said, to find the direction, you use the positive charge. Where it goes, it is the direction of the field. So when you post a positive charge here, where will it go? Is it out or in? Here you have to remember that like charges repel and unlike attract. So when you put a positive charge here, because the charge is positive, it will be repelled, meaning that the direction will be outwards. Just like that. Yeah, then comes this next question. It says, draw electric field pattern for isolated negative charge. Like we said, we have a negative charge which does not have neighbors. How does the field look like? They are straight line fields like that. And then the direction comes in. What's the direction? The direction, you have to put a positive charge here. Where it goes will be the direction of the field. You have to remember that this is negative and the testing charge is positive. So what happens when two unlike charges are close to each other? They attract. So the field will be like this. Yeah. So then comes this question, electric field pattern for two positive charges next to each other. So how does this pattern look like? You have a positive charge here, and the neighboring one is also positive. So how does this pattern look like? You have to know that these ones, they don't like each other. They are like charges. So what happens is that this one tries to move out in a straight line like it was doing when it was isolated. Then it sees a bad neighbor and it curves. So this is how it looks like. Yeah. The same applies this side. It wanted to go straight, then it sees a bad neighbor, and that's how it curves. You have to remember that the next one, the curving is not as strong as the first one because it's further from the neighbor. So the curving reduces, but it's also there. Then you have to remember that there is this one which does not know that there's a neighbor that side. So it goes straight. The same applies to this one. Now this diagram looks very easy and understandable, but many learners lose marks on it. We don't know why. Okay, let's indicate the direction. Remember, we are using a positive charge as the direction determinant. So when you put a positive charge here, where does it go? Remember, this is positive, and the two like charges repel. So it will go out like that. And there we are. This is the electric field pattern for two positive charges next to each other. Yeah, then comes this question. It wants electric field pattern, yeah, for two negative charges next to each other. So what do we have? You have here a negative charge next to another negative charge. They are like, and they hate each other. So what happens is that when this one tries to go straight, it sees a bad neighbor and it curves. When this one is trying to go straight, it sees a bad neighbor and it curves. The curving of the next one is less than that one of the first one because it is some distance from the other charge. The same applies to this side. And the next one, the curving is not as strong as the other one. Then you have to know that there's this one which does not know that there is another neighbor that side. So it goes straight. And the same applies to this one. So after that, what comes next? Direction of electric field. And we use a positive. When you put a positive here, where does it go? You have to remember that what we have here is negative. So when you put a positive, they become unlike charges. And what happens to unlike charges? They attract. So the positive will be attracted towards the negative, and that's what we get. So there we are. This is the electric field pattern showing two negative charges next to each other. So there we are. The next one says electric field pattern for a positive and negative charge next to each other. So what do we have in this case? We have a positive charge and a negative charge, and they are next to each other. They are unlike and they are next to each other. So what happens here? These ones, they love each other. So this is what we see. Thank you. But now you have to know that there are some fluxes which would want to go straight, but they see a good neighbor, so they curve. And there's another one which is supposed to go that one. So that's what happens. The same applies here. It wanted to go straight, like during isolated charge. It says a good neighbor, so it curves. You see, it was supposed to go straight that side. And this one was supposed to go straight that side. It says a good neighbor, it curves. Good people, every line here has a meaning. Then there is this one which does not know that there's a neighbor that side. So for it goes straight. The same applies to this side. It goes straight. After that, what comes next is the direction. You have to know that we use the positive charge to determine the direction. So when you put a positive charge here, where does it go? It goes to the right. Okay. Then we come to these ones. You put a positive charge and this charge is negative. Where does it go? It comes in. This side, when you put a positive charge, what happens? It is repelled because it's the same charge. So there we are. This is the electric field pattern of a positive and negative charge next to each other. So there we are. Yeah, electric field pattern for positively charged solid sphere. So what are you having here? We are having a sphere which is solid. All of it is solid and is positively charged. How does the flux look like? They come out from the sphere directly outside like that. And because it's positively charged, what can we say? That when you put a positive charge here, it will go outwards. So that's what happens for a positively charged solid sphere. So then comes this question. It says electric field pattern for a negatively charged hollow sphere. So what are we having here? We're having a sphere, but inside is empty. It's not solid and it's negatively charged. So how does this look like? Okay, here you have to take note that inside a hollow sphere, there's no charge. So the charge is only on outside. Actually, when you go further, this sphere, we normally use it for electric field shielding. When you have an item like a compass and you don't want it to be influenced by electric field, you put it in a hollow situation so that the electric field cannot influence it. So it is only on outside. And let us have it like that. Inside the hollow sphere, I repeat, there's no charge. It is only on the outside and it's negatively charged. So what does it say? If it's negatively charged, it means that when you put a positive charge, it will come in. So that is our direction. Yes. And with that, would like to thank you for your time. The channel is PSSB. physical sciences. Silver bullet. See you next time. Don't forget to subscribe. Don't forget to like, to comment, to share. Yes, we believe we will not regret. Bye bye.